At present, the state of the color organizer is mostly handled by the Redux store. We also have some state being handled by the router. Specifically, if the root contains a color ID, the presentation state of the application is different than when it does not. Having some state handled by the router may seem contradictory to Redux's requirement. Meant to store state in a single object, a single source of truth. However, you can think of the router as being the source of truth that interfaces with the browser. It is absolutely okay to allow the router to handle any state associated with the site map, in CLUD. In the filters required to look up data, keep the rest of the state in Redux store. Moving color sort state to router, you do not have to limit the use of router parameters. They can be more than filters for looking up specific data in state. They can also be used to obtain information necessary for rendering the UI. The Redux store presently contains the information about how the colors should be sorted in state via the sort property. Would it make sense to move this variable from the Redux store to a root parameter? The variable itself is not data, it provides info about how the data should be presented. The sort variable is a string, which also makes it an ideal candidate for a root parameter. Finally, we want our users to be able to send the sort state to other users in a link. If they prefer to have the colors sorted by rating, they can send that info to other users in a link, or bookmark that content as is in the browser. Let's move the sort state of the color wall to a root parameter. These are the roots that we will use to sort our colors. / default sort by date. / sort title sort by title. / sort rating sort by rating. First, we need to remove the sort reducer from the /store/index.js file. We no longer need it. As a result, combine reducer's colors, sort, becomes combine reducer's colors. Removing the reducer means that the state variable will no longer be managed by Redux. Next, we can also remove the container for the menu component from ./src/compo. nins/containers.js. The container is used to link the state of the Redux store to the menu presentation component. Sort is no longer stored in state, so we no longer need a container. Additionally, in the containers.js file, we need to change the colors container. It will no longer receive the sort value from state. Instead, it will receive sorting instructions as a root parameter that is passed to the color component inside of the match prop. Export const colors equals connect. Colors, match equals. Colors sort colors match.params.sort. Dispatch equals. On remove id. Dispatch remove color id. On rate id, rating. Dispatch rate color id, rating. Color list. Now the colors are being sorted by a routing parameter before they are passed to the color list as a property. Next, we need to replace the menu component with one that contains links to our new routes. Much like the About menu that we created earlier in this chapter, the visual state of the menu will be controlled by setting the active style property of the nav link. Import navlink from React Router. Const selected style equals color red. Const menu equals match equals menu. 2 equals / style equals match dot is exact selected style. Date. 2 equals / sort / title active style equals selected style. Title. 2 equals / sort / rating active style equals selected style. Rating. Export default menu. Now users can sort the colors via the URL. When there is not a sort parameter available, the colors will be sorted by date. This menu will change the color of the link to indicate to the user how the data has been sorted. We need to modify the app component. We need to handle sorting the colors via routes. Const app equals exact path equals / ID component equals color / path equals / component equals app component equals menu / exact path equals / component equals colors / path equals / sort component equals colors / First, the menu needs the match property, so we will render the menu with a root. The menu will always render alongside the new color form and the list of colors because the root does not have a path. After the new color component, we want to display either the default list of colors, sorted by default, or the list of colors sorted by a parameter. These roots are wrapped in the switch component to ensure that we only render one colors container. When users navigate to the home root, http / localhost 3000, the app compo mint is rendered. By default, the colors container is rendered within the app. The value of the sort parameter is undefined, so the colors are sorted by default. If the user navigates to http / localhost 3000 / sort / rating, the colors container will also be rendered, but this time the sort parameter should have a value, and the colors should be sorted by that value. Routing parameters are an ideal tool to obtain data that affects the presentation of your user interface. However, they should only be used when you want users to capture these details in a URL. For example, in the case of the color organizer, users can send other users links to specific colors or all the colors sorted by a specific field. Users can also bookmark those links to return specific data. If you want your users to save information about the presentation in a URL, then a routing parameter is your solution. In this chapter, we reviewed the basic usage of the React router. All of the examples in this chapter incorporated the hash router. In the next chapter, we will continue to use the router both on the client and the server with the browser router, and we'll use the static router to render the current routing context on the server. Chapter 12 React and the server. So far, we have built small applications with React that run entirely in the browser. They have collected data in the browser and saved the data using browser storage. This makes sense because React is a view layer. It is intended to render UI. However, most applications require at least the existence of some sort of a backend, and we will need to understand how to structure applications with a server in mind. Even if you have a client application that is relying entirely on cloud services for the backend, you still need to get and send data to these services. Within the scope of Flux, there are specific places where these transactions should be made, and libraries that can help you deal with the latency associated with HTTP requests. Additionally, React can be rendered isomorphically, which means that it can be in platforms other than the browser. This means we can render our UI on the server before it ever gets to the browser. Taking advantage of server rendering, we can improve the performance, portability, and security of our applications. We start this chapter with a look at the differences between isomorphism and universalism, and how both concepts relate to React. Next, we will look at how to make an isomorphic application using universal JavaScript. Finally, we will improve the color organizer by adding a server and rendering the UI on the server first. Isomorphism versus universalism. The terms isomorphic and universal are often used to describe applications that work on both the client and the server. Although these terms are used interchangeably to describe the same application, there is a subtle difference between them that is worth investigating. Isomorphic applications are applications that can be rendered on one Gert Hengeveld, isomorphism vs universal JavaScript, medium. Pull platforms. Universal code means that the exact same code can run in multiple environments. 1. Node.js will allow us to reuse the same code that we've written in the browser in other applications such as servers, CLIs, and even native applications. Let's take a look at some universal JavaScript. var print names equals response equals var people equals json.parser response.results, names equals people.map name equals name.last, name.first. console.log names.join. The print names function is universal. The exact same code can be invoked in the browser or on a server. This means that if we constructed a server with Node.js, we could potentially reuse a lot of code between the two environments. Universal Java script is JavaScript that can run on the server or in the browser without error. Figure 12:1. Figure 12:1. C. Client and server domains. The server and the client are completely different domains, so all of your JavaScript code will not automatically work between them. Let's take a look at creating an AJAX request with the browser. Const request equals new smushed request. Request.openGet https://api.randomuser.me/ nat equals useResults equals 10. Request.onload equals print name is request.response. Request.send. Here we are requesting 10 user records at random from the randomuser.me API. If we run this code in the browser and look at the console, we will see 10 random names. Ford, Brianna Henderson, Nellie Lynch, Lily Borden, Todd Collins, Genesis Roberts, Suzanne Dixon, Renee Ray, Raphael Adams, Jamie Bowman, MIA. However, if we try to run the exact same code with Node.js, we get an error. Reference error smushed request is not defined at object. /users/ at module.compile module.js 54132 at object.module.extensions.js module.js 55010 at module.load module.js 45832 at true-module.load module.js 41712 at function.module.load module.js 4093 At function.module.run main module.js57510. At startup node.js 16018. At node.js 4493 this error occurs because node.js does not have an smushed request object like the browser does. With node.js, we can use the HTTP module to make a request. Const HTTPS equals require HTTPS. HTTPS.get. https://api.randomuser.me/mat equals useResults equals 10, res equals net results equals res.set encoding at 8. res.onData, chunk equals results equals chunk. res.onEnd equals print name is a source. Loading data from an API with Node.js requires the use of core modules. It requires different code. In these samples, the print names function is universal, so the same function works in both environments. We could build a module that would print the names to the console in either a browser or a Node.js application. var print names equals response equals var people equals json.parser response.results, names equals people.map name equals name.last, name.first. console.log names.join. We can render this component directly in the browser, or render it in a different env. Environment and capture the HTML output as a string. React DOM has a render toString method that we can use to render UI to a HTML string. // renders HTML directly in the browser React DOM.render. // renders HTML as a string var HTML equals React DOM.render toString. We can build isomorphic applications that render components on different platforms, and we can architect these applications in a way that reuses JavaScript code universally across multiple environments. Additionally, we can build isomorphic applications using other languages such as Go or Python. We are not restricted to Node.js. Server rendering React using the React DOM.render toString method allows us to render UI on the server. Servers are powerful. They have access to all kinds of resources that browsers do not. Servers can be secure and access secure data. You can use all of these added benefits to your advantage by rendering initial content on the server. Let's build a basic web server using Node.js and Express. Express is a library that we can use to rapidly develop web servers. npm install Express save. Let's take a look at a simple Express app. This code creates a web server that always serves the message hello world. First, information about each request is logged to the console. Then the server responds with some HTML. Both of these steps are timed in their own function and chained together with the .use method. Express automatically injects request and response arguments into each of these functions as arguments. Import Express from Express. Const logger equals res, next equals console.logreg.method request for reg.url. Next. Const savehello equals res equals res.status 200.send hello world. Const app equals express. .use logger. .use savehello. App.listen 3000 equals To express documentation, using middleware. Console.log recipe app running at http://localhost 3000. The logger and say hello functions are middleware. In Express, middleware functions are chained together into a pipeline with the .use method. To when a request occurs, each middleware function is invoked in order until a response is sent. This Express app logs details about each request to the console and then sends an HTML response hello world. Finally, we start the Express app by telling it to lease 10 for incoming requests locally on port 3000. In Chapter 10 we used the Babel CLI to run our tests. Here we will use the Babel CLI to run this Express app because it contains S6 import statements that are not supported by the current version of Node.js. Babel CLI is not a great solution for running apps in production, and we don't have to use to Babel CLI to run every Node.js app that uses S6. As of this writing, the current version of Node.js supports a lot of S6 syntax. You could simply choose not to use import statements. Future versions of Node.js will support import statements. Another option is to create a Webpack build for your backend code. Webpack can export a JavaScript bundle that can be run with older versions of Node.js. In order to run Babel Node, there is a little bit of setup involved. First, we need to install the Babel CLI, Babel Loader, Babel Preset S2015, Babel Preset React, and Babel Preset Stage 0. npm install Babel CLI, Babel Loader, Babel Preset End, Babel Preset React, Babel Preset Stage 0. Save next. We need to make sure we add a .babel file to the root of our project. When we run Babel node index server.js, Babel will look for this file and apply the presets that we have installed. Presets. Env, Stage 0, React. Finally, let's add a start script to our package.json file. If you do not already have a package.json file, create one by running npm init. Scripts. Start./nodemodules/bin/babel node index server.js. Now we can run our Express server with the command npm start. npm start. Recipe app running at http://localhost 3000. Once the server is running, you can open a web browser and navigate to http://localhost 3000. You will see the message hello world in the page. ctrlc will stop this Express server from running. So far, our Express app responds to all requests with the same string hello world. Instead of rendering this message, let's render the recipe app that we worked with back in chapters 4 and 5. We can make this modification by rendering the menu component with some recipe data using render toString from React DOM. Import React from React. Import Express from Express. Import render toString from React DOM/server. Import menu from ./components/menu. Import data from ./assets/recipes.json. Global.react equals React. Const HTML equals render toString. Equals data /. Const logger equals res, next equals. Console.logrec.method request for rec.url. Next. const sentinel page equals res equals res.status 200.send. React recipes app. HTML. Const app equals express. .uselogger. .user sentinel page. App.listen 3000 equals console.log recipe app running at http://localhost 3000. First we import React, the render toString method, the menu component, and some recipes for our initial data. React is exposed globally, so the render toString method can work properly. Next, the HTML is obtained by invoking the render toString function and sending it the menu component. Finally, we can create a new middleware function, sentinel page, that responds to all requests with an HTML string. This string wraps the server-rendered HTML in boilerplate that is necessary for creating a page. Now when you start this application and navigate to http://localhost 3000 in a browser, you will see that the recipes have been rendered. We have not included any JavaScript in this response. The recipes are already on the page as HTML. So far we have server-rendered the menu component. Our application is not yet isomorphic, as the components are only rendered on the server. To make it isomorphic, we will add some JavaScript to the response so that the same components can be rendered in the browser. Let's create an index-client.js file that will run in the browser. Import React from React. Import render from React DOM. Import menu from ./components/menu. Window.react equals React. Alert bundle loaded, rendering in browser. Render equals data/document.getElement via React container. Alert render complete. This file will render the same menu component, with the same recipe data. We know that the data is the same because it will already be included in our response as a string. When the browser loads this script, the data will already exist in the global scope. The alert methods are used to see when the browser renders the UI. We'll need to build this client.js file into a bundle that can be used by the browser. Here, basic Webpack configuration will handle the build. Don't forget to install Webpack. We've already installed Babel and the necessary presets. npm install Webpack save dev here. Basic Webpack configuration will handle the build. var Webpack equals require Webpack. Module.exports equals entry./index-client.js output. Path assets, file name bundle.js. Module. Rules. Test/.js/exclude/loader modules/loader Babel loader query. Presets env stage 0 React. We want to build the client bundle every time we start our app, so we'll need to add a prestart script to the package.json file. Scripts. Prestart./loader modules/.bin/webpack progress. Start./loader modules/.bin/babel node index server.js. The last step is to modify the server. We need to write the initial data to the response as a string. We also need to include a script tag with a reference to our CLI. End bundle. Lastly, we need to make sure our server sends static files from the ./assets/ directory. Const sentinel page equals res equals res.status 200.send.